Hello friends, welcome back. Hearty welcome to you. Let us look at this problem related to indefinite integrals, inverse functions, trigonometric functions. We have to find out the integral of sine inverse of root of x by a plus x. To solve this problem, first we'll substitute x equals to a tan square theta so that we can simplify the problem. If I put x equals to a tan square theta, what will happen to the value inside the square root? That will be x by a plus x, which is equal to square root of x is a tan square theta divided by a plus a tan square theta, which is equal to a secant square theta. If we simplify, we'll see that this is equal to a cancels. Tan square theta is sin square theta by cos square theta. Secant square theta is 1 by cos square theta. So it will become square root of sin square theta, which is equal to sin theta. That means whatever we have in square root of x by a plus x becomes now sin theta. So let's go ahead to the next step. What we know if x equals to a tan square theta? So by the way, we have here dx. What we know if x equals to a tan square theta? We know dx equals to 2a tan theta into secant square theta d theta. So we can go ahead and substitute that. We'll write down integral of sine inverse of root of x by a plus x is equals to sin theta. We simplified that already, into dx. Dx equals to 2a tan theta secant square theta d theta. So we go to the next step. We can write it as 2a integral of theta tan theta secant square theta d theta. Now if you take tan theta equal to another variable, let us say z. If we take tan theta equal to z, then we know that secant square theta d theta will become dz. That means the problem will become simple. From 3 variables will come down to 2 variables. So let us write down that 2a d theta. We know secant square theta d theta equal to dz. So we can write down that tan theta equal to z. And what is theta? Theta equal to tan inverse of z. And from here we know theta tan square theta equal to x by a, or we also know that theta equal to tan inverse of root of x by a, because tan theta equal to root of x by a, or we can write down here tan theta equal to x by a. That means theta equal to tan inverse of root of x divided by a. So the problem becomes now 2a integral tan theta, that is z is tan theta, and theta equal to tan inverse z. So our problem became now 2a integral z into tan inverse z. So let's go ahead and try to solve this by using integration by parts. In the next step, what we will write down? We'll write down equals to a integral of 2z into tan inverse z dz. Now we will apply integration by parts. When we do integration by parts, we have to choose first and second function. Our first function is tan inverse z and second function is 2z. So we will integrate the second function. It will become a into 2z integral is z square into tan inverse z minus integral of derivative of the first function, that means derivative of tan inverse z, which is equal to 1 by 1 plus z square into z square dz. So when we go to the next step, we will have that's equal to a into integral of z square tan inverse z minus we have integral of z square by 1 plus z square. Why can't we write it as 1 minus 1 by 1 plus z square? So what we have written? Z square by 1 plus z square. We have written it as 1 minus 1 by 1 plus z square, so that we can easily integrate that. So when we go to the next step, we will have a into z square tan inverse z minus integral of dz plus integral of 1 by 1 plus z square dz, because when we open the bracket, minus into 1 will be minus 1 and minus into minus will become plus, so it will be minus dz plus integral of dz by 1 plus z square. We know this is tan inverse z, and we know here we will get minus z. So we are done with the problem. We have to just go back and substitute in terms of x so that we can write down the solution. So let's go to the next step. It will be equal to a into integral we have done that. First part it is done. So z square tan inverse z minus integral of dz is z plus integral of dz by 1 plus z square is tan inverse z. So let's substitute now the values in terms of x. So we can write down z square is tan square theta, and tan square theta equal to x by a. So we can write down x by a. Tan inverse z, that is tan inverse of root of x by a, minus z equal to tan theta, but tan theta equal to root of x by a. So we can write down minus root of x by a plus tan inverse z theta equal to tan inverse z. So theta is equal to tan inverse root of x by a. We can write down that, and we close the bracket. So that's the final solution. So the solution for that is a into x by a into tan inverse x by a minus root of x by a plus tan inverse z. Tan inverse z is theta, but theta is tan inverse of root x by a. So from z we have to go to theta, and from theta we have to go to in terms of x, because the problem is given in terms of x. Our solution also should be in terms of x only. So we got a into z square tan inverse z minus z plus tan inverse z. We know z square equal to tan square theta, but tan square theta is x by a, and the tan inverse z equal to theta equal to tan inverse root of x by a minus root of x by a plus tan inverse root of x by a plus c. That's what we have missed. We have to write down plus c. So that's the end of the solution.